Let's take an example and evaluate a function. Let's suppose you are given, and sometimes books will write given, p of x equals 3x squared minus 5x plus 7. We've got one variable. It looks pretty normal, like the polynomials we've been dealing with, but now we have a relationship between y and x, p of x. We're going to find the value of the function when x is equal to negative 2, p of negative 2. Our solution is simply to substitute negative 2 everywhere there's an x. So let's do that. P of negative 2 is going to be 3 times negative 2 squared. And mind your parentheses. It's important that you remember that the negative goes with the 2 so that it will be squared. Minus a 5 times a negative 2. Let me take this away. Plus a 7. Well, negative 2 squared is going to be a positive 4. Negative 5 times negative 2 will get us a plus 10, plus 7, which is going to be 12, plus 10, plus 7, which is looking a lot like 22, plus 7, and gives us 29. So what we can say is that the value of our function when x is equal to negative 2 is 29. P of negative 2 is 29. If we graphed this point, we would plot the ordered pair negative 2, 29, just to make a link back to the graphing that you've done at other times. And let's just do one more example. That's another way problems are often presented. P of x equal 5 x to the 4th power minus 3 x squared plus 6. Find P of positive 2 this time. Well, again, everywhere we see an x, we're going to put in a 2. So we'll have 5 times 2 to the 4th power minus 3 times 2 squared plus 6. And that will get us a 5 times 16. Using our order of operations, working with the exponents, minus 3 times 4 plus 6, which is going to get us 80 minus 12 plus 6, and eventually we will decide that P of 2 is 74. And that's our answer. To review, our ultimate goal in this section, it involved a definition, but our ultimate goal was to evaluate polynomial functions which are referred to in these examples as P of x. And our method is simply to substitute for x and calculate the answer. That's the end of this segment.